Welcome to the first talk from the IoT track. My name is Andrew Jordan. I'm the product manager here at Twilio for the Super SIM. And today we're going to walk through kind of the stack for the Super SIM and kind of what exactly it is. So everyone who's been in Silicon Valley for a while, I think across the world, has heard the phrase hardware is hard. If hardware is hard, then doing IoT is doubly hard because you have all the challenges of building hardware on top of all the challenges of figuring out how to connect that hardware to the internet. This is something we hear from our customers all the time as they build solutions. And also, kind of one of the reasons we try to ship an IoT device every single signal, like the narrowband kits for this year, is so we kind of put ourselves in that process, can really understand the challenges that people face when they're trying to ship a connected product. And some of the things that make IoT really hard are the stack isn't quite there. For software, we've all gotten accustomed to really nice stacks that work everywhere. If you're a developer and you have a really good idea for a consumer mobile app, like you can lean on iOS, you can lean on Android. If you want to do SMS or video, you can use Twilio. You can do Stripe for payments. You can pretty safely deploy it on AWS in one data center, and then when you need to go regional, you can localize and then kind of stamp out your servers anywhere you need to be in the world. And that's pretty well proven. It's robust, it's reliable, it's not expensive, and there's a lot of best practices there that everyone can agree work quite well. For IoT, this paradigm doesn't exist at all. From hardware selection, module selection, manufacturing, there's no well understood stack that you can point anyone starting out and say, hey, go use these few things and you'll be just fine. And that especially doesn't exist for the communications level, the connectivity layer for IoT devices. And that's really what we're trying to tackle with the Super SIM. And Evan talked about this problem a little bit in his keynote, but this is something we've seen time and time again, is you go out and you decide you're going to build an IoT device. So you kind of design the device, you pick a baseband module for it, you pick a connectivity provider. That connectivity provider gives you, if you're fortunate, some APIs to manage your fleet of SIMs. They also give you a console so you can understand your usage. And at the end of the month, you get a bill for however much you may be charged based on some kind of pooling or bundling or however else the connectivity provider has decided to charge you. And that's all well and good. But then something happens and you get really popular. Maybe you started in North America, now you want to deploy to Mexico, you're going to deploy to Latin America, you're going to deploy to Canada, or you found a niche for your device in Europe. Well, this is a really excellent problem to have, but it's something you're going to kind of struggle to solve. So first of all, you're going to need to figure out if your device needs to be changed for these new regions. Are you going to need to pick a new baseband module that has support for different bands? What LTE bands do you want to support, 3G bands? That you need to sort out. And once you need to sort that out, then you need to pick connectivity providers. And are these going to be, are you going to try to go for a global aggregator? Are you going to try to negotiate direct with a local carrier? Once you figure this out, now you have a bunch of different SIM cards and a bunch of different devices. You need to track your SIM cards. You need to figure out which SIM cards go into which devices. And you need to make sure those are all shipped to the right location. And the same complexity multiplies for consoles. You're consuming usage APIs, SIM lifecycle APIs that are all different depending on the destination you're shipping your SIM. And you get 4 bills in all kind of different methodologies for calculating what your total bill might be. And this is all relatively hard to deal with. It's hard enough that we see a lot of our customers who've scaled globally have teams of 4, 5, 6 people who their job is IoT connectivity management. Their job is to source carriers, handle all the integrations, handle all the billing disputes, et cetera. So we saw this pattern happen over and over and over again, and realized, at Twilio, we build tools to help developers solve problems. This is a problem we kept seeing over and over again, and as the wireless team, we are well equipped to make this happen. So we want to launch the Super SIM to make global connectivity easier. So as a developer, you can put a Super SIM in your device, ship it anywhere in the world, and it should just work. So like we mentioned, we've been doing this for 2 years, shipping a T-Mobile-based SIM. And we've shipped hundreds of thousands of SIMs all over the world. And in the process of working with those customers, we've learned a great deal. So the first, there's no such thing as regional deployments. If you're running a really successful IoT business, you're going to want to expand out of your home market to a secondary market. The support for special cases is really, really important. The connectivity landscape out there is not even, and there is a base case where you just plug in your SIM and it just works everywhere. But there's also tons of edge cases where, for deploying your device into a specific city, the specific carrier doesn't have the LTE band you need, and so you need another carrier. And you, as a device manufacturer, may understand that, and you need the ability to make those kind of choices. And the last is that debugging IoT can be super, super hard. As soon as that device leaves your lab, getting the data off of it, and then understanding how it's connecting to the network and what might be going wrong is a really, really challenging problem. So given those problems, we picked some design principles for Super SIM. The first was, to the extent where possible, we wanted to support the same write once, deploy everywhere philosophy that software engineers get to enjoy. We wanted to make sure the product had smart defaults and also the ability to override. So this is a theme through many Twilio products where out of the box, you should just be able to use it. But if you're a power user and you understand that you're deploying a SIM to Santiago, Chile, and in Santiago, Chile, most carriers are on band 7, but your device only has band 4, and even though that band 4 carrier is twice as expansive, you're willing to pay twice as much because you need coverage on that carrier. So offering APIs that allow the expressiveness to, if you are an expert, to make those choices. And the last thing, we thought the visibility for developers is a fundamentally good thing. So as much visibility as we can provide to developers, we wanted to ship in the product. And that led us to the Super SIM, which we were thinking not so much as a product, but as a platform, the long-term platform for global IoT connectivity. And this platform is made up of 3 different layers that we've put together for the Super SIM. Network, SIM, and our packet core, and we can go into each of these in depth. So the network is extremely important. No matter how clever you are with your software, how your SIM's designed, if you don't have good networks behind it, it's not going to matter. So as you heard Christine talk about yesterday, at Twilio, we have this concept of the super network. And the super network is a carrier abstraction layer that takes carrier connectivity, aggregates it, and then manages on behalf of a developer. As a developer, you don't really care who your underlying carrier is. You don't want to have to make that choice. You just want your connectivity to be plentiful, inexpensive, and low latency. And with the Super SIM, Twilio takes on the responsibility of making those optimizations on behalf of developers. So who are the operators that we're partnering with for the Super SIM? So like I said, 2 years ago, we started our relationship with T-Mobile. And for the Super Network, we're adding 3 new operator families. We say operator families because these aren't people who own just one network, but clusters of networks which are centered around certain regions. For Latin America, we're partnering with Telefonica. For Western Europe, we're partnering with the 3 Group. And for Asia and the Pacific, we're partnering with Singtel. These are really strong network operators who have really strong local specialties and also a really robust global footprint. Through the combination of these carriers, we can get you to any network in the world at a good price. It's important to bring on carriers, but also think about how you're bringing them on. One of the core principles of Twilio is fault tolerance and high availability. So as we bring on carriers, you generally do this through an intermediary called an IPX provider. You can kind of think of the IPX network as a private internet for carriers. If you bring on a bunch of carriers and you integrate them all through the same IPX provider, you have a single point of failure now, where if that IPX provider goes down or has issues, it doesn't matter how many carriers you have behind them, you still can't reach them. So we're thinking about diversity not just in the network or the operators we're bringing on, but also how we're connecting them into our core. And this feeds back to how we think about the Super SIM as kind of our long-term platform. Right now, Super SIM offers kind of the standard access technologies that we're all really familiar with. On the Super SIM, we offer 2G, 3G, LTE. We also offer a flavor of LTE called Cat M1, which is another low-power LTE protocol. In the future, we want to have all the technologies on this SIM. So then we'll be adding narrowband, and as 5G support becomes more widespread, we'll be adding 5G as well. We kind of see the IoT market splitting, where kind of you have your high consumption devices. You can think automotive, scooters, anything where the asset itself is really expensive or it's revenue generating, where you don't, like, cost isn't so much the issue. You want high bandwidth and you want low latency. We see that as critical IoT, and the current best generation technology for that is LTE. And we also see kind of it's splitting, where you also see a whole new class of devices where they're really latency insensitive. They don't need high bandwidth, and you just want it really, really cheap and power efficient. For massive IoT, we see narrowband and Cat-M being the technologies for there. But for the Super SIM, you shouldn't need to make that choice up front. We should be able to support all these technologies on a single SIM. So let's talk a little bit about the SIM itself. How many of you are really familiar with SIM cards? Like have manufactured one or designed one? Yeah, me neither. Like as a consumer, you know what a SIM card is, right? You get it from a carrier, you slip it into your phone, and like magically it does stuff, and now you can access the internet. Turns out they're actually like quite a bit more sophisticated than that. I kind of imagine them to be on par with like a micro SD card, right? Some like dumb storage, and there's probably some keys on it, and it works. They're actually pretty smart. They have like a 5 megahertz processor. There's some RAM. They run Java card. It's like a whole Turing-complete computer sitting in your phone, run by a carrier. They come in a really wide range of form factors and durabilities. We'll go into that later. And fortunately, they're extremely, extremely well specified. And for the most part, people do kind of mostly follow the spec, which is super important. We kind of take for granted that you can pull a SIM out of an IoT device, put it in your iPhone, pull it out of that, put it in a car, and it all seems to work. And that's more or less true. So let's get a little deeper into SIM cards and talk about three emerging technologies for SIM cards, which are kind of frequently confused, but really important to understand when you're doing an IoT deployment. The first concept is the embedded SIM. An embedded SIM is a form factor of SIM card. If you looked at a consumer SIM card, you're really familiar with kind of like the gold-plated contacts. The chip itself is considerably smaller than that and is wired underneath the substrate that the chip is embedded into to the gold contacts on the SIM. So the module itself is quite small. And embedded SIMs have really taken off because they're smaller, they're more durable, and they're soldered directly onto the board at the point of manufacture. If you have a Google Pixel or a Apple Watch Series 3 or the new iPhone XS, your phone has one of these in them. What's notable about them is they're very often confused with eSIM. So where embedded SIM is a form factor of SIM card, eSIM is a protocol or more a solution for swapping the contents of a SIM over the air. If you can think about embedded SIMs, okay, great. So at manufacturer, like they're actually pretty cool. They come on like this long ribbon, so you can feed them into like an industrial pick and place machine. So you kind of imagine somewhere in a factory in Shenzhen, there's like a little robot kind of pulling them off, and like, which is great. And then you think about how are you going to get a profile on there, and what if you want to change it? Like you're not going to go through and ask the robot to resolder it. So there needs to be a specification for changing the contents of that SIM without physically removing it. And eSIM is that solution. And I think what's two important bits. First of all, once again, eSIM is a solution, not a form factor. So you can do eSIM on really any SIM card. You can do it on a removable SIM card. You can do it on embedded. The initial iPads that Apple shipped with like the Apple SIM was an eSIM compatible removable SIM. And what's important about eSIM is it's exactly analogous. Swapping between one profile and another profile with eSIM is exactly the same as removing a SIM. You get totally new IMSIs, you get totally new KIs and CKs, which are the encryption keys that authenticate you to the network and allow you to update them over the air. It's like a full change. And the last concept I want to talk about is multi-IMSI. So multi-IMSI gets you some of the benefits of eSIM without some of the drawbacks. So for multi-IMSI, IMSI is International Mobile Subscriber Identifier. It's how carriers identify themselves to each other on the mobile network. So when your T-Mobile phone in your iPhone turns on, it goes down to the SIM card, pulls up an IMSI that identifies you as a subscriber, and then presents it to the network and says, like, hi, I am this T-Mobile subscriber. Here's my IMSI, and then you're authenticated. So a multi-IMSI SIM has many of these IMSIs loaded in parallel on a Java card applet on the SIM. Why that's important is it allows us to do things like put Telefonica and Singtel on the same SIM. So depending on the region you go to with this SIM, you can write logic into the applet where as the phone boots up, the terminal will call down to the SIM, will pass in its current location, we'll take that location, applet will parse it, go to a lookup table, figure out what operator should be used in what priority for that particular region, and then that's the IMSI that the SIM will then present back up to the handset. What's also important is with multi-IMSI, unlike eSIM, where every time you swap, you bring in new carrier authentication keys, and when you bring in new carrier authentication keys, you're actually bringing in like a whole new mobile core backend. With multi-IMSI, you can have multiple providers and still use a single mobile core, a single backend. So if you wanted to make the kind of like the turducken of SIM cards, all three of these concepts are compatible with each other. So you can have an embedded eSIM compatible multi-IMSI SIM. So if you think about like kind of to separate all these things in your head, embedded is just a form factor. So you guys are used to kind of like full size, micro, nano. You can think of embedded as the next smallest size of SIM cards. eSIM allows over the air changes of the profile, and multi-IMSI allows the SIM to switch providers. So what do we do for the Super SIM? The Super SIM is available in all the different form factors. So if you want 2FF, 3FF, 4FF, those are like the full-size, micro, nano, embedded. And then SIM vendors also will sell you various durabilities of those cards. So there's the industrial one, which has more writes and has a higher temperature range. So if this thing's gonna be sitting out in the sun, you don't want it to melt. And then also automotive, which is designed for super long life. Like cars have a 10-year lifespan, so you want to make sure your SIM doesn't burn itself out through continual writing. You can buy really durable automotive cards. So we support kind of any of the different form factors and also any of the durabilities. The Super SIM does run a multi-IMSI app. That's the thing that fundamentally allows us to run all these operators on a single SIM. And we support mobile-to-mobile eSIM. It's important to note there are two specifications currently for eSIM. One is the consumer one, which if you're like me and waiting for Apple to figure out that iOS update that allows you to use the eSIM in your phone, people are figuring out and is kind of slowly being adopted. The other, which is for machine-to-machine, is a totally different specification for mobile-to-mobile. And that's something we can do today. Entering that specification requires you to spend a lot of money on specified solutions from SIM providers. It's really painful and expensive, but if you're interested in doing it, we can do it for you. So that's great. Like we've decided how we want to build a SIM. We've gone through and done all this testing on the SIM. We've gotten them from the manufacturer, plugged them into our SIM readers, plugged them in our devices, tested the settings, make sure the IMSI switching works, worked on optimizing kind of all the settings within the SIM, and we think we have a candidate for that SIM that's going to be the one we're going to ship. We're super excited. But then we realize as soon as we ship these, they're kind of frozen in time. How do we make sure that we can continually update them? And for that, we have an over-the-air update platform. So this is mostly for tuning the carrier connectivity and the IMSI table. When we talked about the operators that we added for the Super SIM as of today, you notice there's like some geographic areas that we're not covering. We don't have a specific carrier for Africa. So say we acquire a new carrier relationship for Africa. We can then go over the air, update, insert that operator's IMSI into our multi-IMSI app, reset the table. So for like the specific African countries that they cover, set that up, and then push that out over the air to our existing fleet. So either for SIMs that support SMS, we send it out as an SMS. There's a more modern way to have SIMs as they boot, make a hook out to a server over HTTP and ask for a payload and bring that payload down to rewrite the SIM. So we kind of have two methods for keeping our SIM fleets up to date. And this is how we want to bring the power of the super network, kind of a carrier level that's abstracted, that's always improving, that we want to bring it to our fleet of SIMs. So the last part I want to talk about, and I talked about this a little bit earlier, talking about how if you swap keys, you swap cores, is a piece of fundamental infrastructure that is the backing of all mobile networks. And this is the packet core, the thing that kind of sits in the middle. Once you authenticate to a mobile network, it authenticates to this core, and then all your packets are routed through it. So we've deployed a pure software mobile core in AWS. And this has all the benefits that we've all come accustomed to for cloud. So scalability, high availability, quick iteration cycles, a multi-tenant model, which makes it really resource efficient. And this is what Twilio really specializes in. And since we already have a pretty large existing footprint in AWS, we can run the internet breakouts. You can think of these like the exit nodes for IP traffic through any of our data centers. And we can do this in a way where as your SIM connects, we pick the exit node for you automatically to ensure that you have the lowest possible latency for the packets between your IoT device located somewhere in the world and the server those packets are trying to get to. This is my gratuitous like cloud animation or cloud photo. It's like very like analyst-y, like embrace the cloud. So the software mobile core, the thing we're really excited about is it brings the mobile core under Twilio's control, which really kind of, if you go back to Chetan's point about experimentation unlocks innovation, we're really, really excited to have this new toy and the teams to iterate on this mobile core. So as customers develop new requirements, as opposed to saying like that's really cool, but the core doesn't do that, we can say, yeah, let's figure it out. So we're on track to do 1,000 deployments a year, and this also gives us complete visibility for network attachments and data flow. Like I was talking about the design principles for the Super SIM, one of the principles was to give developers as much visibility as we could all the way through the stack. Now that we own the mobile core, we can see your signaling and media packets from the time it hits the edge to the time it exits. And that allows us to do things like push them all into Elasticsearch. So if we want to build like Elasticsearch-based search tools, so you can see like which of my device IDs are coming in Brazil, online in Brazil, and attaching to Claro, and what is the average duration of the PDP context? These are questions that we can answer for you. I think this is the things that we're really, really excited about. As we've been operating this service with our customers, we found this to be incredibly useful to our teams for operations. And as we expose this to customers, we know they'll find it similarly useful. I talked a bit about kind of the level of specificity that we want to give developers as they start deploying their solutions, and how if you're like we don't want to require you to be an expert in order to use this product, but if you happen to be an expert, we want to give you the power to put that expertise to work. So we're working on defining a new, we're calling it network access list primitive within the Super SIM. So you as a developer can go in and say, here are exactly all the networks I want whitelisted. Here are exactly the networks I want blacklisted. You should be able to apply this configuration at the rate plan level, so like at a group level. So you can say all my SIMs which belong to my DVT group, should have this level of access. But then you should be able to go in and granularly override for a single SIM and say, this individual SIM should have different black and white lists because it's special in a way that you understand. So this is the stack that Twilio has developed. We have a network we're incredibly proud of with partners that we think are rock solid. We have a SIM, which is of our own design, offered in a ton of different mediums and durabilities. We have an elastic packet core deployed in AWS in pure software that we can continue to iterate on. Like Evan said, this is available spring 2019. We currently have a couple 100,000 Super SIMs out in the wild. We're developing this product with some of our existing Twilio Wireless customers to make sure that we can make it really rock solid and keep the group small so we can provide them the best software or best service while we iterate on the product. If you have any Super SIM questions, my name is Andrew Jordan. I'm the PM for Super SIM. This is my email. Please email me directly. Thank you. Sorry, I ripped through these slides. If you have any Super SIM related questions, I will be over in this corner right after. Would love to chat about SIM design, yeah, anything we talked about today. Thank you very much.